Hey viewers, welcome to my channel Gasp Tech. This is the 14th video in the series of Python programming, and in this video we're going to see about different operations that can be performed in using NumPy arrays. So in the previous video we have seen the indexing of NumPy arrays, how to index multidimensional arrays and how to slice smaller arrays from a bigger array, right? And in this video we're going to see some operations that can be performed using NumPy arrays. So first basic operations are the arithmetic operations. So unlike list, arithmetic operations can be performed between two arrays of same dimension. So here's an example. Here I created a two-dimensional array and stored it in the variable A, and another two-dimensional array that is stored in the variable B. And when I perform A plus B, it performs addition, element-wise addition. So 1 plus 1, 2, 2 plus 4, 6, 3 plus 3, 6, 4 plus 3, 7, 5 plus 2, 7, 6 plus 1, 7. So it performs element-wise addition. So let me demonstrate you here. So A equal to np.array of 1, 2, 3, 4, 5, 6. So I created a two-dimensional array, and I'm creating another two-dimensional array. So let me just reverse the numbers, okay? 3, 2, 1, and 6, 5, 4. So I have created two-dimensional arrays. Now I can perform addition, A plus B. So it performs element-wise addition. 1 plus 3, 4, 2 plus 2, 4, 3 plus 1, 4, 4 plus 6, 10, 5 plus 5, 10, and 6 plus 4, 10. Now if I try to do the same with list, so list is probably one-dimensional, right? So x is equal to 1, 2, 3, y is equal to 4, 5, 6. Now if I try x plus y, it actually performs concatenation. The plus symbol is used for concatenation when you are dealing with lists or tuples. So if you want to perform addition of two arrays, so NumPy array is the way to go, right? You cannot do them using list. Maybe you can use a for loop to add the numbers in two lists. But if you want to add two arrays of same dimension, then NumPy array is the way to go. Okay. Similarly, you can perform subtraction, A minus B, right? 1 minus 3 minus 2, 2 minus 2 0, 3 minus 1 2, 4 minus 6 minus 2, 5 minus 5 0, 6 minus 4 2. So that is the subtraction. And you can perform multiplication. 1 into 3 3, 2 into 2 4, 3 into 1 3, 4 into 6 24, 5 into 5 25, 6 into 4 24. That is multiplication. And you can perform division. So all the basic arithmetic operations you can perform. Rather than using the arithmetic operator symbols, you can also use inbuilt functions in NumPy array. So they provide functions like add. It performs the same thing. So the addition it performs. Instead of using the operator plus, you can use the function, right? Similarly, you have subtract, you have multiply, you have divide. Okay, so you can use the function instead of the operator. So these are all the arithmetic operators, right? Then considering the other operations, first one, reshaping the array. So let me show you here. So in array A, we are having 2 rows and 3 columns, right? It's a 2 cross 3 array. So totally 6 elements are there. I can change this into 1 cross 6 array. Okay, I can write a dot reshape, right? 1, 6. When I say 1, 6, it means 1 row 6 columns. So it will give me a row vector. Alright, and if I say 6, 1, it gives me a column vector. So this is reshaping of NumPy arrays. The next function is concatenation. So you can either use concatenate or you can use vstack or hstack. So I'll show you. If I use concatenate, I have to give the axis. So before that, let me show A and B. I'm going to concatenate these two matrices, right? np dot concatenate. I need to give both the matrices inside a tuple, right? Within a parenthesis A, B. I need to mention the axis in which I am going to concatenate. So see what happens when I put axis 0. So the concatenation happens vertically. So this matrix, right? This array is placed below this array. So 1, 2, 3, 4, 5, 6. Below that 3, 2, 1, 6, 5, 4. So one is placed below the other one, right? And if I put axis as 1 instead of 0, if I change the axis as 1, A, B, axis is equal to 1. This will concatenate horizontally, right? Axis, equal to 1. Did I make a mistake? Yeah, it's a typo, concatenate a comma b comma axis equal to 1. So that will perform horizontal concatenation. So this particular matrix is placed to the right of this matrix, right side of this matrix. So 1, 2, 3, 3, 2, 1, that will be first row, 4, 5, 6, 6, 5, 4 will be second row. So instead of doing this, I can use head stack or weed stack. So if I write np.headstack a comma b, I need not mention the axis. So what happens? It is getting stacked horizontally. The second array is placed to the right of the first array. If I put v stack, then the stacking will be happen vertically. Stacking happens vertically, right? So this is the concatenate operation. So the requirement is that both the arrays should be of same dimension if you want to concatenate them. At least same dimension across one dimension. Okay, then splitting of array. I can split the array, right? So again, let me show you. np.split array. I'm going to split A in axis 0. NumPy has no attribute split array. I'm doing some kind of mistake here. Array underscore split. So my bad again. So I messed up with the command. So array underscore split. Sorry guys. So array underscore split of a comma axis is equal to 0. Again, I'm missing something. Okay, my bad again. Array underscore split, right? I need to mention how many matrices that I'm going to split. So I'm going to split A into 2. So I need to mention that number. That is my bad. Okay, right. Now what happens? When axis is equal to 0, it splits the first row separately and second row separately. So splitting is happening vertically, vertically, right? Now if I put axis equal to 1, that will give me a horizontal split. So A comma, I am splitting into 2 matrices along the axis 1. So what happens here? 1, 2, 4, 5. See here, this is A, right? So 1, 2, 4, 5. So this is taken as one matrix, and 3 and 6 is taken as another matrix, or rather array. So it is split into unequal arrays. When we are splitting across rows, so first row also has 3 elements, second row also has 3 elements. So it is split into equal dimensional arrays. But when I split across columns, what happens here? So there are 3 columns, you cannot split into equal size. So it is split into unequal sized, right? So this is the speciality of array underscore split. But there is other option, head split or v split. But this head split and v split can be used only when you can divide into equal sized. So let me show you. I need not give axis here. So I simply have to give np dot head split of a comma 2. What happens? It does not do it because it can do it only in equal division. Unlike array underscore split, it cannot do unequal division. But the vertical split will work just fine because it will divide, the 2 rows are in equal dimension, right? So that will work perfectly. That will work fine. But when you try to do horizontal split, so when you are using array underscore split, that was possible. The array underscore split function divided the given array into unequal sized arrays. But here, the head split can only do it as equal sized. So since equal size is not possible, it is throwing up error. So this is the splitting function. The next function is the where command. Okay, I can determine the indices of a particular value in your array. Say, let us take A again. I want to know where 6 is located. Where is it located? This is row 0. This is row 1. So it is located in row 1, and with respect to column 0, 1, 2, it is located in column 2. So the position is 1, 2. Okay. Now let us see. np.where A equal to 6. So I am using the assignment operator here. Where the element is equal to 6, find the location. That is what it does. So row 1, column 2. So that is where I am having 6. Okay. Now suppose I want to print the locations where my values are less than 4 or less than 3 rather. So where I am having value less than 3, the first 2 elements. So what are the indices? For 1, the row is 0, column is 0. So 0, 0. For 2, row is 0, column is 1. So 0, 1. So 0, 0 and 0, 1 will be your answer. So this where command will come in really handy when you go for further topics or further aspects of Python programming. Then we have np.reciprocal. This is similar to a numeric operation. So this is A, right? So np.reciprocal of A. So it will perform the reciprocal of each element. So 1 by 1, the answer is 1. 1 by 2, it is supposed to be 0.5, but the data type is taken as integer. So it is giving only the integer portion. 1 by 3 is supposed to be 0.33, but it is showing only integer portion. So let me convert the output to floating point so that we can see the actual answers. D type equal to float. There you go. So 1 divided by 2, 0.5. 1 divided by 3, 0.3333. 1 divided by 4, 0.25. 1 divided by 5, 0.2. Likewise, it performs the reciprocal of individual elements. Now again, next one is power. So it performs exponent operation. np.power of a, 2. What this does is, it performs a square, that is power 2 for each element in the A. 1 power 2, 1. 2 power 2, 4. 3 power 2, 9. 4 power 3, 4 power 2, 16. 5 power 2, 25. And 6 power 2, 36. So it performs the power 2 for each element. Right? Suppose, now we have A and we have B. If I give np.power of A, B. So what this will do is, it will take the array A as the base elements and array B as the exponent elements. So 1 power 3, the answer will be 1. 2 power 2, the answer will be 4. 3 power 1, the answer will be 3. 4 power 6. So 6 times if you multiply 4 by 4, that will be the answer. So likewise, this will be taken as the base and this will be taken as the exponent and you will get the corresponding values. So this is what power function does. Next we have modulo division or remainder. Both the functions you can use. So it performs division and gives you the remainder. So np.mod of a, 2. So I am going to divide each element of a by 2 and give the remainder. So first element is 1. 1 divided by 2. It will not divide. So the remainder is 1. 2 divided by 2. The remainder will be 0. 3 divided by 2. The remainder will be 1. For odd number, remainder will be 1. Even number, remainder will be 0. Right? So that is what is happening here. So it performs modulo division. The next function is a range. So this creates a range of numbers. This function comes in very handy. Sometimes we will be using this function in the conditional statement of for loops as well. So pay attention to this function. It is very good, a special function. So x equal to np.range of 5. So what it does is, it creates an array of numbers starting from 0 till the end minus 1. So we are given 5 here. The number we are given 5. So 5 minus 1, 4. So 0 to 4, it creates an array. So 0, 1, 2, 3, 4. If I give np.range of 6, it will create from 0 to 5. Okay. So it creates a range of numbers. Now suppose, I will show you another important, speciality of Python here. So I am creating range of 9. Okay, so 0 to 8 it will create totally 9 numbers. 0, 1, 2, 3, 4, 5, 6, 7, 8. Now, I am going to reshape. So whatever I create, so here I have given a range of 5. So it has created a 1 cross 5 matrix. Now if I give a range of 9, it will create a 1 cross 9 matrix. So that I am going to reshape as 3 cross 3. So in a single command, I can perform two functions. I can create a range of numbers as well as reshape that resulting array. So this is another functionality of Python. You can do multiple operations in a single command. So now if I print x, you see here 0, 1, 2, 3, 4, 5, 6, 7, 8. Instead of giving it as a single row, it is giving it as a 3 cross 3 array. So this is another very good speciality of Python. Then transpose, you know pretty well. So let me print a again. So np.transpose of a. That will convert the row to column and column to row. So I am sure you must be aware of transpose. And last one is sort. For sort operation, let me just take b here. So if I put np.sort of b, comma, axis equal to 0. Let's see what happens here. There is no change, right? Axis equal to 0 means it will try to sort vertically. So 3, 6. It is already sorted, right? The sorting will happen in ascending order. So 3 is the smallest and 6 is the largest. It is already ascending. 2, 5, it is already in ascending order. 1, 4, it is already in ascending order. So nothing has happened to the original matrix. Now suppose if I try to do it in the other dimension, b comma axis equal to 1, this will try to do in the horizontal dimension. So 3, 2, 1, if I arrange it in ascending order, what will become? 1, 2, 3. Similarly, second row will become 4, 5, 6. So now it performs sorting operation in the ascending order. So these are all some of the functions with respect to NumPy arrays. So thank you so much for watching the video. If you like the video, hit the like button. Do give your valuable suggestions in the comment box, and if you want more such videos, do subscribe to my channel. Thank you, viewers.